So this is a problem in which we can sum all of the forces that are acting on the central sphere. And we can do this because of superposition. Another thing to note is that we can simplify this problem dramatically by using symmetry. So M1 and M4 both have a mass of 5 grams. Due to this, that the pull this way of M1 and the pull this way of M4 cancel each other out because they have the same mass. Now, of course, that only works in this particular moment. As soon as the central sphere starts to move, that will no longer be the case. But for now, we can do that. And what's nice is because M1 and M4 cancel, we know that the direction of the force on the central sphere will be directed along the slope y equals x. So it will be going in this direction. And each of these are vectors. Each of these will be vectors in which M2 is pulling with its mass of 3 grams, and M3 is pulling with its mass of 1 gram, so we can actually eliminate M3 and just consider M2 2 grams. So we will do that. We will say that M2 is 2.0 grams. Another thing to note is that we can easily determine this angle by noting that that distance, which is 10 centimeters, and this distance, 10 centimeters, are the same. So this should be 45 degrees. What we have is this beautiful equation from Newton, that the sum of the force of gravity equals the gravitational constant times each mass. So we'll say this is mass 5 multiplied by our simplified mass. We'll just call it ms for our simplified mass. And it's divided by the distance between them squared. So this will equal 6.67 times 10 to the negative 11. That's Newton meter squared per kilograms squared, multiplied by mass 5, which is, whoa, what happened here? I'm missing mass 5, which I happen to know is 2.5 grams. I've already done this problem, so I know that it's 2.5 grams. Okay, so we have, 2.5 grams, except we don't want grams. We want these masses to be in kilograms. So 2.5 times 10 to the negative 3 will give us our kilograms. This will be 2 kilograms. All of this divided by the distance between them squared. What is this distance, this whole distance here? This distance, the whole distance, not the curved distance, the straight line distance here between them. That can easily be determined by the Pythagorean Theorem. And we have 10 and 10, so we need the square root of that. So it will be the square root of 10 centimeters, but centimeters doesn't really work because this number here is not centimeters. That's in meters. So it'll be 10 times 10 to the negative 2, and that'll give us our meters. And that is the distance, and the whole distance is squared. If we plug that into our calculator, newtons. Just note that the meters cancel out, kilograms cancel out, and we're left with newtons. And we'll probably round it to there. So let's determine the net force. So this is the force of gravity on M5. It's pulling at that, and we need to convert this into unit vector notation. So this is our magnitude. This is the magnitude that we're working with. And we already know what the angle is, 45 degrees. So to convert this into unit vector notation, which is what it asks for, we'll just call it F net. The net force, the vector of the net force, will be the magnitude, which is 1.67 times 10 to the negative 14. Well, this is the x component, so it's cosine of the angle, and that's newtons. And this will be 1.67, because it's the y component, it's sine of the angle. Which, if we multiply that together, we'll get 1.18. And this will be I hat for the x component. Oops. And j hat for the y component. And that's it. That's our answer. That is complete.